So what does practice do in our brains to make us better at things? Our brains have two kinds of neural tissue, gray matter and white matter. The gray matter processes information in the brain, directing signals and sensory stimuli to nerve cells, while white matter is mostly made up of fatty tissue and nerve fibers. In order for our bodies to move, information needs to travel from the brain's gray matter down the spinal cord through a chain of nerve fibers called axons to our muscles. So how does practice or repetition affect the inner workings of our brains? The axons that exist in the white matter are wrapped with a fatty substance called myelin, and it's this myelin covering or sheath that seems to change with practice. Myelin is similar to insulation on electrical cables. It prevents energy loss from electrical signals that the brain uses, moving them more efficiently along neural pathways. Some recent studies in mice suggest that the repetition of a physical motion increases the layers of myelin sheath that insulates the axons. And the more layers, the greater the insulation around the axon chains, forming a sort of superhighway for information connecting your brain to your muscles. So while many athletes and performers attribute their successes to muscle memory, muscles themselves don't really have memory. Rather, it may be the myelination of neural pathways that give these athletes and performers their edge with faster and more efficient neural pathways. Frequent repetitions with allotted breaks are common practice habits of elite performers. Studies have shown that many top athletes, musicians, and dancers spend 50 to 60 hours per week on activities related to their craft. Many divide their time used for effective practice into multiple daily practice sessions of limited duration. And finally, practice in your brain in vivid detail. It's a bit surprising, but a number of studies suggest that once a physical motion has been established, it can be reinforced just by imagining it. In one study, 144 basketball players were divided into two groups. Group A physically practiced one-handed free throws, while Group B only mentally practiced them. When they were tested at the end of the 2-week experiment, the intermediate and experienced players in both groups had improved by nearly the same amount.